This is a chapter integration for paper 1. Integration is often referred as the reverse process of differentiation. Previously, you learned that differentiation is the process of obtaining dy by dx when y is known. For example, consider the following functions. Suppose we have y is equal to x cubed minus 7. So here y is known. We want to find dy by dx. So we differentiate y. We obtain 3x squared plus 0. When we differentiate minus 7, which is a constant, we obtain 0. A second example. If we have y is equal to x cubed plus 4, dy by dx is 3x squared plus 0, or simply 3x squared. Third one, if we have y is equal to x cubed plus half, again dy by dx is 3x squared. A last one, if we have y is equal to x cubed minus 0.1, dy by dx is 3x squared. So here we can see that when we have y is equal to x cubed plus a constant, the constant can be positive or negative, we obtain dy by dx as 3x squared, c being a constant. So this is a process of differentiation. From y, we obtain dy by dx. Now we have to go back. That is, we know dy by dx. So for integration, we know dy by dx. We have to find an expression for y. So this reverse process is known as integration. So in this case, here, if we have to integrate 3x squared with respect to x, we would have obtained y is equal to x cubed plus c. We have seen that there are an infinite number of functions that when differentiated give the answer 3x squared. All these examples, when we differentiate, we have 3x squared. So y is of the form x cubed plus c. Integration symbol. So this symbol is used to denote integration. As you can see, it is an elongated S. So for the above example, we can write integral of 3x squared with respect to x is x cubed plus c. Also, integral of 3x squared is called the indefinite integral. It is called indefinite because it has infinitely many solutions. So when we have dy by dx, we integrate to obtain y. Similarly, when we have f dash of x, when we integrate, we obtain f of x. So just like when you differentiate y, you obtain dy by dx, and when you differentiate fx, you obtain f dash of x. Now it is the reverse. Let's now see the technique for integration. The first one is the integration of power function. Or instead, if we have to integrate x power n with respect to x, so we write it as, we use a symbol of integration, the elongated s, and we write x power n dx. So for this type of function, when we integrate, first of all, we add 1 to the power. So it becomes n plus 1. And then we have to divide by the newly obtained power. That is, we divide by n plus 1. And then we have to add the constant of integration c. And here n cannot be equal to minus 1. So there is a restriction here. Because what will happen when we add 1 with minus 1, we obtain 0. And then when we divide by 0, the function is undefined. Let's take some example. The integral of x power 5. So first of all, 5 plus 1 is 6. This is the new power. And then we divide by the new power, which is 6 plus the constant of integration. We can write it as 1 over 6 x power 6 plus c. Suppose we have x power minus 3. So, minus 3 plus 1 is minus 2. And then we divide by minus 2. Plus c. You can write it as minus half x squared. X power minus 2. We put it in the denominator, it becomes x squared plus c. If we have x root of x, integral of x root of x. So we can write it as x power 1. Here we have power half. So we add the two powers, we obtain x power 3 over 2. And now we integrate. 3 over 2 plus 1 is 5 over 2. And then we have to divide by 5 over 2. So when we divide by 5 over 2, it is the same as multiplying by 2 over 5. So this is the integral of x root x. 2 over 5, x power 5 over 2. And then we must not forget the constant of integration, because these are indefinite integral. Now what will happen when we have to integrate a constant? Suppose we have to integrate 2 with respect to x. So 2 is the same as 2 times x power 0, because x power 0 gives us 1. So these two are the same. Now we apply the above technique of integration. So we obtain 0 plus 1 is x power 1, and then we have to divide by 1. So we obtain 2x. If we integrate 10, so this will become 10 times x power 0. It will become 10 x power 1, and then divide by 1. We have plus c. Forget the plus c, plus c. So the answer is 10x plus c. So if we have 100, integral of 100, it will become 100x plus c. If we have integral of half dx, it will become half x plus c. If we have 1 dx, it is x plus c. Therefore, we can conclude that if we have integral of k, it will become kx plus c. We just have to multiply by x. Now if we have to integrate kfx dx, that is, we have a constant multiple of a function. So we can put the constant outside, and then we simply integrate the function fx with respect to x. So if we have integral of 3x power 4, so this will become, so here we have plus c, so we can put, we have a constant multiple here which is 3. We can write it as 3 integral of x power 4 dx. So we leave the 3 outside, and then we integrate x power 4. This becomes x power 5 over 5 plus c. Next we can multiply multiply it to obtain 3 over 5 x power 5 plus c. If we have half x power 5 to integrate, again we have half and then we integrate x power 5. So half and then we integrate just x power 5. So it's x power 6 over 6 plus c. So it's 1 over 12, 2 times 6, x power 6 plus c. If we have 4 x power minus 3 over 2, so it becomes 4 integral of x power minus 3 over 2 x minus 3 over 2 plus 1 is minus half, and then we have to divide it by minus half plus c. So it's 4 times minus 2 minus 8 x power minus half plus c, or we can write it as minus 8 over root of x plus c. Now we have the third rule for integrating sum and differences of two functions. If we have integral of fx plus or minus g of x with respect to x. So for this type of function, we have to integrate each function separately. So we integrate fx with respect to x plus or minus, and then we integrate g of x with respect to x. The same apply if we have 3 or more functions, f of x plus g of x plus h of x and so on. So we integrate each one separately, just as we did with differentiation. Now examples. Suppose we have dy by dx is equal to 4x cubed minus 2x power minus 2 plus 4. So when we integrate dy by dx, we obtain y. So y is the integral of 4x cubed minus 2x power minus 2 plus 4 with respect to x. Now we have to integrate each one separately. We have 3 functions here. So the first one, 4x cubed. So the 4 remains here. X power 3, it becomes x power 4, and then we divide by the new power, which is 4. Next one, we integrate minus 2, x power minus 2. So the power become minus 2 plus 1 is minus 1, and then we divide by the new power. And here we have a constant 4. So when we integrate a constant, we just have to multiply it by x. So it becomes 4x plus the constant of integration c. So final answer is x power 4 minus 2 divided by minus 1 is plus 2. X power minus 1, we can write it as x in the denominator plus 4x plus c. The fourth type of function that we are going to integrate is of the form ax plus b power n. This is a composite function, and here again n cannot be equal to -1 and a also cannot be equal to 0. And this ax plus b must always be a linear function. So for this type of integrals, the answer is, so if we have to integrate ax plus b power n, so we take ax plus b, again we add 1 to the power n, this becomes n plus 1, we divide by the new power, which is n plus 1, and then also we have to divide by this function, the differential of this expression of ax plus b. So when we differentiate ax plus b, we obtain a. We have to divide also by a, and then plus c. So I repeat, this ax plus b must always be a linear function. So we take n, we add 1, it becomes n plus 1. This is the new power. We divide by the new power, that is by n plus 1, and then we have to differentiate the expression inside the bracket. That is, we have to differentiate ax plus b to obtain a. Again, we divide by a. So this is the integral for ax plus b power n. And n, the power cannot be equal to -1. Let's take an example. Integral of 2x minus 3 power 4. So this becomes 2x minus 3 power 4, we add 1, becomes power 5. We divide by 5, and then the expression inside the bracket is 2x minus 3. We differentiate 2x minus 3, we obtain, so the differential of 2x minus 3 is 2. We then divide by 2, so we have 2 in the denominator. So it's 1 over 10 in 2x minus 3 power 5 plus c. A second example. Integral of 20 over 1 minus 4x power 6. So we write it as 20 1 minus 4x power minus 6. So we can take 20 outside the integral. We obtain 1 minus 4x power minus 6 dx to integrate. So it's 1 minus 4x power minus 6 becomes minus 5. We divide by minus 5, and then we have to divide by the differential of 1 minus 4x. When we differentiate 1 minus 4x, we obtain minus 4. Then we divide by minus 4. So 20 over 20 is 1. So we have only 1 minus 4x power minus 5, which can be written as 1 minus 4x power 5 plus c. So this is the end for the first lesson on integration for paper 1. Thank you for your attention.